welcome. So, A group is here. I'm going to tell you why this is doing this in a second, because I haven't told them yet either. And those of you who are at home today, you have to watch this video, and then you have questions. Tomorrow when you come to class, I'm going to check your Chapter 2 notes. Also in Chapter 2, I do know that the section on specific heat is not there. I don't know why. It's not opening up on the Google Classroom for some reason. So I will help you fill in those notes tomorrow or Friday. I'll leave it up, but I better do it for you guys while you're here. Also tomorrow, it's like weird lighting. Also tomorrow, A group, B group, you have a vocabulary quiz over roots 1 through 10. A group, was the vocab quiz easy?
Yes.
Yes. Easy points. Make sure that you study. Okay, other things. This is here. I'm going to hit it a lot. They took down my projector yesterday. I've already dropped my camera once today. And they put this television in, which is super awesome. But the cord doesn't reach yet. So Mr. Robinson is at Walmart getting a cord. So somebody just said hi to somebody whose name I can't see. Say out loud, but you probably heard. Okay, so let's go ahead and get started. Today we're finishing the chapter. A group, you guys will need to watch the video tomorrow to review, because when you watch the video! Because tomorrow, tomorrow we review for the test. The next time that I see you, A group, you're going to have a test on Monday. And B group, your test is Tuesday. Wednesday, Thursday might be the only days that you have to watch video. I'm sorry, Thursday, Friday might be the only days you have to watch videos, because we might all be back together 4 days a week. Fingers crossed. They're having a board meeting Tuesday, I think.
If we all go back, is it still possible to get signed?
See, I'm
Yes.
Yeah,
Okay.
I'm not.
Yeah, we're all doing that.
Thinking about how you've been doing on Cyber Days,
Yeah, true.
do you think that it's a good idea?
No.
Also, the Cyber, just so you know, I've had a lot of students,
Oh, I said that.
I've had a lot of students come back from Cyber because it's not through us, it's through the IU. And so it's really, really difficult.
Yeah, I'm gonna stay.
So I would suggest that you stay here, because in my opinion, the teachers are awesome.
Yep.
Good answer. Don't turn around and whisper.
I wasn't. You showed me his new pencil though.
I mean,
Yeah.
Oh,
Yeah. Okay.
yeah. Wait, I got a question. I want to come back. Does that mean we'll be able to be like that close? Someone?
I don't exactly know how that's going to work, because I have lab tables. So since I have lab tables, I think that you two sitting next to each other is probably a bad idea.
I don't even like him.
Yeah, nobody does, but.
What?
So I don't know what's going to happen. All right. Craziness happening. Here we go. Someone in this room right now, raise your hand and tell me why ice floats.
Whoa.
Because
it's
less
density.
corrosion.
Its density isn't as dense as water.
Yes. What were you going to say?
She just said yeah.
It's more so.
It's the density.
Okay. Here's my question. Turn around, you.
No, it's the mass.
Here's my question. Be completely honest. How many of you actually watched the video from Tuesday? All the way. Okay. Because if you would have watched the video on Tuesday, you would know that the answer to this, whenever you say ice is less dense than water, I'm going to tell you that was a great answer when you were in 3rd grade.
I started it, but then.
But now we need a big kid answer. So, yes, ice is less dense. Solid water is less dense than liquid water. But the reason why it's less dense is what I'm looking for. So all you're doing is just telling me a fact. Okay, so solid water is less dense than liquid water. However, the reason why is because of this. Mouse.
It's freezing. It's because there's air inside that not.
Kind of. So everything on the planet, when it freezes or when it goes to the solid form, what does it do? I'm going to stand right here separate.
They're all combined.
The molecules get closer together, right? So everything on this planet, when it goes from a liquid to a solid, the molecules get closer to each other. I don't have my shield on. I'm sorry. Okay, yes, it gets closer. They get closer to each other. Except for water. Water is the one thing on this planet that is different. When water freezes, the space between the molecules expands. So the molecules themselves do not expand. This is a water molecule, that's a water molecule. It's weird because I can touch this, and on my old screen I couldn't touch or would advance it because it was a touch screen, so this is weird. Okay, this is a water molecule. Water molecule, water molecule, water molecule. This size does not change when it freezes. The size of the water molecules is going to stay the same, but the space between them is going to get bigger. So if you were to tell me that water expands, that is still technically not correct because that would mean that those molecules get bigger. The molecules themselves do not get bigger. The space between the molecules get bigger. We say they hold each other at arm's length. If we weren't in the middle of a pandemic, I'd have you guys come up here. I'd have like 3 of you, and I'd have you hold hands, and then I would have you like, no, stop touching. I would have you hold hands, and then you would like spread apart or get closer to each other depending on what state of matter you were in. We are not going to do that right now, but normally under anything else in this on this planet, if it is in, hey, ladies.
Ooh, my Achilles.
If there was, wow, are those champion slippers, shoes? Huh. Neat. Okay, you would be crying more if you tore your Achilles. Do you need help?
No.
Should we call the nurse?
No.
Did you just like hit your Achilles on the thing?
Dalton, kiss his boo-boo, make it
No, no. Are you okay? Like, really? You were just sitting there. How did this happen? Okay.
He's good.
Thank you.
Can you feel better?
Okay. So, everything else on the planet, when it's in solid state, the molecules are like this. Except water. When water freezes, it's the space between the water molecules is going to expand because of those hydrogen bonds. Any questions on that? Okay. Solutions. A solution is a mixture. And in the mixture, there is a solvent that is dissolves the solute. So the thing being dissolved is the solute. The thing doing the dissolving is the solvent. So if I have hot chocolate, the water is going to be my solvent, and the hot chocolate mix is going to be my solute. And what we learned the other day as well, gentlemen, please, is that polar can only dissolve polar. So if I'm trying to find something like tea, so tea is basically water, it's going to dissolve the sugar because sugar is polar and the water is polar as well. Please sit up. Thank you. Concentration is how much of that solute is dissolved in the solvent. And a saturated solution is going to be one where you cannot dissolve anything else. Do they still have those like little Crystal Light packets at lunch? Okay. So if you have a bottle of water and you put one of those Crystal Light packets in, is that the appropriate amount? I don't know. Do you have to put 2 in?
20 ounces. Or 16.
It's the appropriate amount. If you put 2 in, it's going to be too much.
It's too much. But it's still going to dissolve, right? Stop arguing about it. It's still going to dissolve, right? Like you're not going to have whatever. So if you put 3 in, it's still going to dissolve. It's going to be stronger. What if you put like 15 Crystal Light packets in? Is it going to continue to dissolve? No, it's eventually going to be oversaturated. It's going to be saturated. No more can be dissolved. Yes?
So what about like looking at the bottom of the bottle when you shake it up and you're still stuck at the bottom? Does it dissolve?
Well, it could dissolve. You probably just need to put in more energy, so you would need to shake it more.
Yeah.
So you shake it.
So you shake it. Shake it.
No.
Shake it like a Polaroid picture. Uh-huh.
Outcast.
You don't shake it.
Yes!
Oh, I should get bonus points.
Yes.
Let's go.
How about electrolytes? Ooh, we see this a lot. So electrolytes, what does that make you think of when you see that?
Gatorade.
Gatorade. Right.
Yeah.
So electrolytes. Did anybody ever see the movie? I think it's called Idiocracy.
No.
I love
It's
this.
from like 19. That sounds.
It is from like 1990 because I'm old. And I think I saw it as a rerun, so it might be even older than that.
1984. 85.
I'm not that old. So with that one, with that movie Idiocracy, it actually is kind of a good parallel for what is going on now. But anyway, these people are dying because they don't have enough food, because they only water their food with Gatorade, or whatever the TV name for the Gatorade is. And they're all like, it has electrolytes in it. But what are electrolytes? Don't read the definition. Does anybody know, like, for real?
They are.
Okay. Why do you drink Gatorade in your football games instead of just water?
So you get hydrated.
So you get hydrated because what?
You can stop sweating.
Because you're sweating. Right. And what are you releasing whenever you sweat?
Yes.
Homeostasis.
Salt.
Salt.
That's why you taste like it.
That's why you taste salt. Right. So if you're like you're playing a game, or you're exercising or whatever, and you get some sweat into your mouth, it tastes salty, or you get it in your eyes and it burns because it's salt. Exactly. So whenever you drink Gatorade, it's replenishing your electrolytes, it's replenishing your salt. So you have to have the appropriate salt to water ratio in your body, in your blood. Otherwise, it's bad. I'm coming.
Who is that? They're going crazy.
I am videoing right now on, okay.
Whoa.
Okay, thank you very much. I'm almost done, but I'm recording.
That was wow. He
He's really trying to break the door.
I know. Well, I could tell it was him because he was doing that. So the electrolytes, the salts, right? So that Gatorade is going to be replenishing the salts. It's replenishing the salt that's in your blood to help keep the water amounts correct. Because what's that word? Striped shirt. Homeostasis, exactly. Mostasis, because like mostasis, mo problems.
Yep.
Yep. Yes.
Okay, so I've heard with Gatorade, if you're not drinking it while sweating, it can actually dehydrate you.
Maybe if you have too much salt. Right, so we're going to talk in chapter 5 about the osmotic balance of like everything. We may, if we're all back together, do a lab.
Whoa.
But we have to, like, it involves food. But it won't work if we're like, that might not be a good idea.
Can we eat the food?
Yes, not the one that we experiment on, but I'll bring extras.
I'll eat one.
But it won't kill you, it'll be
I'll
okay.
take one for the team and I'll just eat the experiment.
It's not going to kill you.
That's what I just said.
We like take gummy bears and put them in cups with different amounts of water and with different amounts of salt in the water and see what happens to the gummy bears. So you end up with like really salty gummy bears. It won't kill you, but
I want to play with acid.
everybody like touches them, so that would be bad.
You say battery acid?
No, like acid, like just put your finger in acid.
It might burn a little bit.
That really nice one where like take
Yeah. Okay, so that's good there. Acids and bases. Whenever we have a solution, you don't have to write that down. That's awesome. I do love having you
I know.
do that. Write the notes down. Yes.
I found out today that most of serial killers save the marshmallows from Lucky Charms last, and that's what I do.
Huh.
So I might be.
Mask break. So if you couldn't hear that, somebody just said, I read
Whoa.
that serial killers eat the marshmallows last in Lucky Charms.
They do. It's a
See, I used to
How many of you?
Most serial killers.
So should we be calling the cops right now? Or?
No. So,
I do though.
but how many of you eat the marshmallows last?
I do it every single time.
Yeah. So do I. And like 4 people doesn't make me a serial killer. So,
1 in 4 people are always serial.
like, I don't know. Isn't there like a number? Like once I hit like 5 or 6 or 7, then maybe I'm serial. But right now it's just like occasional.
You walk past 3 people in public that are actually mass murderers.
Where? I don't think these sound right.
Yes, I do.
Let me talk about acids real quick, and then we'll be done.
Your kids in their basement, you just don't know.
Here, let me just do this. Acids, so water. Hey. Up here. Acids. So water is water, obviously. And what is the chemical formula of water?
H2O.
H2O. So when we put an acid in water, it's going to release hydrogen ions. Okay, and I'm going to show a picture in a second. Bases are going to release hydroxyl ions. Whatever, I'm just going on here. Here we go. Here's normally. Normally you have an equal number, so the way that they combine together, oxygen can never be by itself. So oxygen, always, you never just have O. O has to be with something else. So even in the atmosphere, atmospheric oxygen is O2. Ozone is O3. Oxygen doesn't stay alone. It is not stable enough to stay by itself. So it's going to dissociate into hydroxyl and hydrogen ions. So here, if you're looking, which you should be looking up here and not toward the back, you would see that these are an even number. If you have an acidic solution, we have more hydrogen ions, H pluses. If you have bases, they have more hydroxyl ions. Okay. And we measure this on the pH scale. Neutral is 7. This should be just a review for you from Mrs. Cox's class. Blood, like human blood, is 7, and water is 7, because human blood is water, basically water with dissolved stuff in it. Things that are closer down to 14, those are very alkaline or very basic. They like Ugg boots and pumpkin spice lattes. Get it? Oh, pity laugh, thank you. Basic, yeah. Things the up here, up towards 0, those things are very acidic. So when we are looking at things, say you have like lemon juice, and then you want it to become more alkaline. Yeah, you can put some bleach in it, and that would be what's called a buffer. It's going to make this, quiet please, it's going to make this lemon juice become less acidic, and it'll make the bleach become more basic. Some of these things you like don't mix together though. What is it? Is it bleach and ammonia that'll kill you? Don't mix that together.
Because of the chemicals in it, you can breathe in.
Right. Here's a question. Say you have, what's it called? Heartburn. What do you take for heartburn? Tums, right. So your heartburn, your stomach acid, you'll notice I'm plugging this thing in. You will notice that your stomach acid is really, really, really acidic. Up here, gastric juices. Then you take Tums. Tums are basically milk with magnesia. So what it does is that those Tums are a buffer. So it's going to help lower the gastric juice that's in your esophagus. So your stomach, you can't see me, your stomach is here, and then your esophagus runs from the back of your throat down to your stomach, and it's going to carry food. There is a sphincter muscle. A sphincter muscle is a circular muscle, right? So that circular muscle is going to help keep the stomach acid inside of your stomach, but it doesn't always close. So you might have acid reflux where that muscle isn't closing like it should close. And so some of that gastric juice, some of that stomach acid is going up into your esophagus and causing heartburn. So when you take that milk of magnesia, it helps neutralize the acid that's in your esophagus. Hang on. Any questions about this? Okay, so I'm going to go back to the specific heat stuff so that those who are in class can fill in their specific heat notes. And there we go. And B group, I will see you in class tomorrow. Don't forget to finish your notes with the exception of this. I'll show this to your classes tomorrow. And you have a vocab quiz tomorrow. And yeah, I said the notes. Have a good day. I'll see you tomorrow.